Let's go. We're going to review converting fractions to decimals and decimals to fractions because we covered it pretty quick, but we're going to review it now. And then we're going to look at percentages just to make sure we're all on board with how to convert those all around. So, converting a fraction to a decimal. There were a couple techniques that we had to do this successfully. First of all, I'll toss this in here. I'm going to zoom it in to make your life a little easier. One of the things that we can do in converting fractions to decimals is to use fractions we memorized. There were a chunk of fractions that I encouraged you guys to memorize. Let's go up here and write them down. I encourage you to memorize the following. I encourage you to memorize quarters. If you memorize a couple quarters, it makes your life a lot easier. Quarters will go so far as to give you halves if you need them. But quarters can also give you eighths. Because 8 is half of 4, 4 is half of 8, so actually an eighth is half of a quarter. So you can divide your way down to figure out what the eighths are, if you really need to. Or you can long divide these, which is the technique that we're going to write here in the box. So quarters are the ones I encourage you to memorize here. Tenths are an easy one to memorize. Tenths give you fifths if you haven't memorized fifths. Because 2 tenths is a fifth. 4 tenths is 2 fifths, etc., etc. You have 2? Okay. Is anyone missing one? Did I miscount? Oh, you grabbed 2. I didn't hand them out. Never mind. Tenths and fifths, I encourage you to memorize both, but if you didn't memorize both, you only want to memorize the one. The tenths will give you the fifths, because these are just simplified versions of some of these. I also gave you guys a tool to memorize the ninths. The ninths is just the numerator repeating, and the ninths actually will give you the thirds. And the thirds can actually go ahead and give you the sixths, believe it or not. Which, the only thing then that we're missing are the sevenths, and I will never ask you to memorize the sevenths. The sevenths will now and forever always be terrible. To figure out the sevenths, you've got to long divide, or pull out a calculator, but I'm not letting you use a calculator. So, long division it is. So we can use the fractions we memorized, or we long divide. How do we long divide? We divide the top number, and it's always the top number, by the bottom number. The mistake that I often see students make is they will divide the bigger number by the smaller number. No. Fractions are always top divided by bottom. Doesn't matter which one's bigger, doesn't matter which one's smaller. It's always top divided by bottom. Thank you. Word. I agree with, yeah. I know you, I appreciated you agreeing. But there's another technique here that we looked at a little bit already, and we're going to look at again today. If you can, it can be convenient to change the fraction, and this is going to lead us to percentages. Change the fraction to be over a power of 10. And so when I say a power of 10, the numbers I mean are 10, 100, 1,000, 10,000, etc. If you can take whatever your fraction is and write it as an equivalent fraction with one of these in the denominator, it's going to be really, really easy to convert. So I'm going to do the first one, 3/4, each one of these ways, and show you how each one of these techniques works. So I'm going to zoom in here. There we are with 3/4. And technique number 1. Use fractions we memorized. 3/4 is what? We really should all know this. 0.75. Because it's 3/4, you guys should be familiar with money. As soon as you get a debit card, sometimes we forgot how to use change. But 3/4, literally this is a quarter. 3 of those is 75 cents. So 3/4 is 75 cents. Done. We memorized it. That's great. Let's say we don't know that. You're brand new to Canada. You've never seen a quarter before in your life. Like, what the heck is this stupid money with a deer on it? Let's long divide. Long division, you know. It's always the top number divided by the bottom number. So then the question is, does 4 go into 3? No, obviously not. It can't go into 3. That's why we wrote it as a fraction to start with. But we don't want to do that, so don't say that, Raven. Bad. You agreed with me before, and now you're making things worse. So, Raven, no, you weren't. No, not. I don't have a dog. So, Raven, what we do instead is we toss a decimal down there and we make it a number that we can put 4 into. We added 0 on there, and now it's into 3.0, which is a lot like dividing it into 30. When you put the decimal down here, we put the decimal above. Review of long division with decimals. And we take a look here and we say, okay, now does 4 go into 30? Raven? Yeah, it does. How many times?
7.
You betcha. 7 times 5 is 28, and we subtract. It's 2. 30 minus 28 is 2. 4 doesn't go into 2, so add another 0, bring it down. I don't have a lot of room, but thankfully I don't need a lot of room. How many times does 4 go into 20? 5 times. Because 5 times 4 is 20. 20 minus 20 is 0. And we're done. Oh, look. The answers are the same. When you do math 2 different ways and get the same value, this is good. We should get this the same way. That's long division with a fraction. Now I'm going to model the last one I said. Change the fraction to be over a power of 100. Let's take a look at this. Let's say I've got 3/4 and 3/4 rather, and I want to write this as an equivalent fraction over 100 or over 10 or over 1,000, whatever. Let's go through them in order. Can I multiply 4 by a whole number, an integer, and get 10? Shobit says no. Shobit, you are correct. Can I multiply 4 by a number and get 100? Shobit says yes again. Shobit, what's the number? 25. It's 25. Because 4/4 is $1. So 4 times 25 is going to be 100. So I'm going to multiply the denominator and I'm going to multiply the numerator. I'm going to get 75 over 100. And we're going to look at it again on the next page, but when you divide by 100, that's the same thing as moving the decimal twice. Boom, boom. There we go. 0.75, and we're done. And while you're on your way back, Jackson, the handout you need is on that table there right next to Charlie. Well, kind of diagonal to Charlie. So there's 3 ways that I've modeled to do all these kinds of questions. Stuff we've already done before. So let's do a quick one here. 35 over 2. Someone pick one of the 3 ways you want me to do this question. I'll pick on someone. Eeny, meeny, miny, Caitlin. How do you want me to approach this question? You just pick a method, I'll do it. Long division, converting to a fraction over 100, or using a fraction we already know to make our life easier. What do you mean?
What?
Using a fraction we already know? Let's use it. Yeah, we can use a fraction we already know. This isn't as bad as it looks. So if I'm going to model using a fraction we already know, and I've got something improper, let's make it mixed to make our life easier. 2 goes into 35. 17 times. Because 2 times 17 is 34. Which leaves us with 1 left over. And oh, look, I know what a half is. A half is what? 0.5, someone said. So this is just going to be the whole number, 0.5. Done. Love it. Jap neat. I'm going to do the next one here. I would like you to pick a different way of doing, which way would you like me to demonstrate this problem? You want me to long divide this? Thank you so much. Here we go. I'm going to take the numerator and divide it by 5. Not what I was hoping you'd say, but I'll do it anyway. Here we go. How many times does 5 go into 12, Rabin? Stop touching Ruben.
Out of his hair.
Rabin, that's his hair. He can get it out if he wants it out. How many times? It goes in twice. 2 times 5 is 10.
Minus, that's 2.
You betcha. And now we're going to add a decimal because we're not done yet. We're going to bring it down. When I add the decimal there, I have to add the decimal there. So does 5 go into 20?
Yes.
How many times? 4 times. 4 times 5 is 20, and that's 0. So 12 over 5 is 2.4 as a decimal. It does not matter how you choose to do this. You just have to be able to do it. Okay, next one. Jackson, wake up. Okay, we've done this one already too. I want you guys to do me a huge favor here and scribble out this garbage. New me doesn't like what old me wrote down here. We're going to scribble that out. Converting a decimal to a number, or sorry, decimal number to a fraction is easier than this. Why write it out? Let's just do it. When you're converting a decimal to a fraction, all you need to do is look at what place the last digit is in and make that the denominator of your fraction. So what place is the 5 in? Is it like the tenths, hundredths, thousandths? What's the place value? Someone said hundredths. That's cool. So 100 is going to be the denominator of our fraction, and then the entirety of the number is what we're going to put in the numerator without the decimal place. If there's a 0 out front, we don't need to include it. So this is just going to become 25 over 100. And now, we reduce, always and forever. We will reduce our fractions. Someone tell me what 25 and 100 are both divisible by. 5. They are both divisible by 5. Indeed they are. 25 divided by 5 is 5. 100 divided by 5 is 20. Are we done? Someone said divide by 5 again. Brielle, was that you? You're right. 5 divided by 5 is 1. 20 divided by 5 is 4. And we're done. This is decimals into fractions. Let's do the next one. 1.2, that 2 is in what spot? The tens, Rabin said. He is correct. So that becomes the denominator on our fraction. Was it not you, Rabin? Was it someone else?
I said something that sounded like 10.
The 2 is in the 10th spot, so the 10 becomes the denominator. And we take the entire number and we shove it in the numerator. So this is going to become 12 over 10. Can I reduce that fraction? You betcha. What can I divide by, Rabin? 12 over 2 is?
6.
10 over 2 is?
5.
And we're done.
Oh my gosh, I'm
Things get uglier when we have more than 2. What is the last decimal place there? That is the thousandths. So we have 175 over 1,000. So numbers that end in 0 and 5 are both divisible by 5. So here we go. Buckle up. This is going to be nice and fun. 10 divided by 5 is 2. 100 divided by 5 is 20. So 1,000 divided by 5 is probably going to be 200. 10 over 5 is 2, 100 over 5 is 20, 1,000 over 5 is 200. This is where things get gross. We will have to long divide this, because I don't know it in my head. So 175 divided by 5. Okay, Raven, go.
5 times 15, 20, 20. No, 5 times.
How many times is 5 going to 17?
Oh, 17? Oh, yeah, my bad. Oh, 3, 3. 5 times.
3 times 5 is 15. Do the subtraction. 17 minus 15 is 2. Drop the 5.
5.
You betcha. 35 is our answer. So this is going to become 35 over 200. Are we done? No, Ruben, because both of these are divisible by 5 again. 35 divided by 5 is the easier one in this case. 35 over 5 is, you have your multiplication tables with you if you don't know them quick enough, but it is 7. And 20 divided by 5, sorry, let's do it this way. What is 20 divided by 5? 4. So what is 200 divided by 5? 40. And that is done because 7 is prime and 40 is not divisible by 7. So there are ways to do this, all of this. Sometimes it gets nasty. That should be review. We've done this already this chapter. Let's look at the next one. Writing percentages as decimals. Here we go. What does percent mean? Do I have, ooh, yes. Was that you, Marcus?
Yeah.
How do you know it's out of 100? Or you learned that in grade 8. There's a real good reason why it means out of 100. Does anyone know why this means it's out of 100? Cent, C-E-N-T, means 100 in what language? En français.
Oh.
This literally means per 100. And the name tells us what to do. If I want to write a percentage as a decimal, it's nice and easy. There's 2 ways we can look at this. We can divide the percentage by 100. 2 ways to do this. And I'm not going to call this a shortcut. I'm going to call this a technique. Let's get rid of the word shortcut. I don't like mathy shortcuts anymore. We're going to call it techniques. Right, Mr. Keeley? We don't like the word shortcut. We call them techniques. Do I have a calculator? Yeah. So you seem frustrated by this. Okay, here we go. So this is going to become 15 over 100. Everything here is percent, means per 100. There is a technique that we use when dividing by 100. Dividing by 100 is the same as moving the decimal place. How many places which way? Does anyone know? Jackson, wake up. I know you're not asleep, but your head's down. I want you up. Be up. Dividing by 100 is the same thing as moving the decimal place twice to the left. So if I have 15 over 100, this is the same thing as having 15 and I move the decimal place twice, 0.15. So let's shortcut this. 5% then is going to be 5 over 100. The decimal that isn't there, I'm going to add to the right of the 5. I want to move it twice. And we add a 0 into any empty holes. That's going to become 0.05. And we're done. So what's 100% going to be then? It's going to be 1. Love it. So the technique is to move the decimal 2 places to the left. So let's crank these out real quick. 55% is what as a decimal? It's 55%.
Oh,
0.55. Love it. Someone else. 7% is going to be 0.07. You have to move the decimal place twice and put a 0 wherever there's a hole or a gap. So then 240% is going to be, yeah, 2.4. You thought you were being tricky, Raven, but you were actually correct. It's awesome when it works out that way. When you're ready, flip the page. Decimals as percentages is easy, as well, easy-ish as well. This is just the opposite of what we just did. Instead of converting a decimal to a percentage, instead of going a percentage to a decimal, we're going decimal to percent. In this case, instead of dividing by 100, we are going to multiply by 100. What is the technique for multiplying things by 100? It's not a shortcut, it's a technique. Anyone want to take a guess based on the previous technique? If when we divide, we move the decimal place 2 to the left. When we multiply, we're going to same amount to the right. 2 places to the right. And if we're converting it into a percentage, you need to write the percent sign. Got to make sure we toss that in there. So then, I'm going to skip this first line. I'm going to straight to the second line. What is 0.34 as a percent? 34%. We move the decimal 2 places back to the right. Boom, boom. 34%. How about 0.08? 8%. How about 2.1? Yeah, we have to move it twice. 1, 2. Add a 0. So I heard 2 of you say 210%. Love that. Okay. This is where the little bit of work comes in today. We want to write percentages as fractions. I know I'm going quick. If you've got questions, please stop me at any point. Writing percentages as fractions. These two down here and writing fractions as percentages are the most amount of work of anything we're going to do today. But you can do it, I believe in you. When writing percentages as fractions, because percent means per 100, we write the value of the percent as the number over 100, and then we reduce. And it's often the reduction, when I say reduce, I also mean simplify. And it's this reduction / simplification that can, depending on the numbers, be the most amount of work. So 25% is just going to become 25 over 100. And I think we've already done this reduction already. Both of these are divisible by 5. So it's going to become 5 over 20. I can divide by 5 again, and it's going to become 1 over 4. Five percent is the same thing. You take the 5, you write it as a fraction over 100, and we reduce. Both divisible by 5. 5 divided by 5 is 1. 100 divided by 5 is 20. At this stage, maybe it's useful to write down all the things that 100 is divisible by nicely. 100 is divisible by the following numbers: 2, 4, 5, 10, 20, 25, and 50. That's it. Well, also 1 and 100, but we don't need to write that down. So if the number you have in the numerator isn't divisible by those things, you can't reduce it. So I'm going to change this number. Instead of 35%, let's call this 37%. 37% as a fraction is going to be 37 over 100. That's the first step. And is this thing reducible? Can I divide 37 by 2, 4, 5, or 10? Or 20? I can't. I'm done. This is it. This 37 over 100 is your final answer. That's all she wrote. And now I saved the best for last. Writing fractions as percentages. And this is the last. I know I'm hearing sighs. It's the end of the day. You guys are tired. This is the one that students are often the most concerned with, and so this is the one that we absolutely need to make sure we get. To actually do this, like I'll give a student a grade on a test, and I'll be like, oh, I got 22 out of 50, or 22, no, I got 22 out of 50. Yeah, sure, I got 22 out of 50. What's my percentage? Well, you should be able to convert that, so let's do it. When I'm writing fractions as percentages, the only way you can actually go about doing this is long division if I don't give you a calculator. That's it. There will be tricks for making the division quicker, but that's it. And then when you're done the division, to turn it into percent, we want to move the decimal 2 places to the right. We're multiplying by 100, and we're adding the percent sign. So we're going from a fraction to a decimal, and from a decimal to a percent. So I'll do one example, and we'll call it a day. And then you guys will work on stuff. So 5/6. Let me zoom in on this little question. It's such a simple looking fraction. Let's see what we can do with this. Long divide. If you got 5 out of 6 on a quiz, what percent did you get? The numerator goes inside. The denominator goes outside. 6 does not go into 5 because that's the whole point we wrote it as a fraction. So I'm going to add a decimal there, and a 0 there. And now we go. Does 6 go into 50?
Yeah.
How many times, Raven?
8.
Thank you, Gershon, whose name is not Raven. But you were just trying to help a brother out, right? So 8 times 6 is 48. 50 minus 48 is 2. Add a 0, bring it down. Does 6 go into 20? How many times?
4.
Nope. 3. Because 3 times into 20, yeah. 3 times 6 is? Oh yeah, Raven, you see where this is going. 20 minus 18 is 2. Add a 0, bring it down. These are zeros. I'm writing them sloppy. Yeah, you can see where this is going. This is repeating.
How long is it?
Forever. I could be here till I died if I wanted to. I don't.
Who says that that way?
Died? It's a natural part of life. This is a science class. We'll allow it. So that's a decimal. I want to take this decimal. I want to convert it into a fraction or a percentage. So I move the decimal twice. This is going to become 83.3 repeating percent. Actually, I lied. We're going to do one more. Okay. Let's do the 2/5. What is 2/5 as a decimal? Does anyone remember? You could long divide, or you could use one of these memorization ones.
40.
It's 0.4. Yes. I didn't want you to take it all the way to the end. You're going to take it all the way to the end of the sec. 1/5 is 0.2, one of the ones I encouraged you to memorize. So then, 2/5 is double this, 0.4. So that's 0.4. I'm going to move the decimal 2 spots to the right. Any gaps get a 0. So as Gershon already said, that's going to be 40%. So there's long division, or sometimes there is a shortcut available to you. And I'm done. I do understand that you've only got about 10 minutes left in the block. But I want you to work to it. Flip the page. Here's your homework. I want you to do it all. All of it. Some of them are really easy. You could crank out most of this. Most of you should be able to crank out most of this in the next 8 minutes. I know that looks like a lot, but you can do it. I believe in you. If you got any questions, let me know. On your market set, giver.